So hello friends, welcome back to my channel. Today we'll be looking at a pretty straightforward problem called as course schedule 2, which is problem number 210 in LEETCODE. So the basic idea of this problem is you will have a set of courses and there will be some dependency in between the courses in the form of prerequisites. For example, in order to take course 1, you have to complete course 0 before taking course 1. So there is a dependency between course 1 and 0, and you will be given the dependency in the form of your missionaries, and you will be asked to return the order in which I can take the courses. So this is a pretty straightforward problem on topological sort. So we will jump into the whiteboard and see what kind of solution we can apply. If you consider the sample data, you will find that each course can be represented as a node in a graph, and the edge between the nodes will be the dependency between them. For example, if the dependency is like this, which means that in order to complete course 2, you should have completed course 1, and also you should have completed course 3. So the dependency can be drawn as like this. So the directed edge between node A and node B mentions that you have to complete course B before taking course A. So you see this is a directed graph, and you can't take any courses if there is cycles. For example, if there is like 3, 2 again, which means like there is a directed graph between 3 and 2. Which means you have to complete 2 before taking 3, and you have to complete 3 before taking 2, which is a cycle. So this is a directed acyclic graph, and you have to return the order in which the courses is taken. So the course which has 0 dependencies will be completed first. So in general that is the case. Here 1 and 3 does not have any dependencies, so you can take 1 and 3 or 3, 1 in any order, and then you can take course 2. So this kind of technique is called as topological sorting. Topological sorting is a famous algorithm that is applied in directed acyclic graph. So the main idea of topological sorting is arranging the elements of the graphs such that if there is any edge between U to V, then V should always come before U. That's the main idea behind topological sorting. So how are we going to apply topological sorting here? So if you consider this problem with just a simple problem. So you have 3 courses, 0, 1 and 2, and 0 is dependent on 1 and 1 is dependent on 2. So we will start from node 0 and we'll check its dependency. So 0 has a dependency on 1, so we'll go to 1, and we'll check the dependencies of 1. So if 1 has a dependency, we'll go to 2. Here 1 has a dependency 2. So we will take the dependencies of 2. There is no dependency for 2, so we will add 2 to array, and we will come back here. We will see if 1 has any other dependency. If it has something like 3, we will add 3 to the array, but here there is no case, so there is no other dependency for 1 other than 2, so we will add 1 to the array, and then we will move back here. If 0 has any other dependency, we will branch out in that way, but here 0 has no dependencies, so we will add 0 to the array. So we will apply a recursive depth first search to move forward in the dependencies and find the node which has no dependencies. So we will jump into the coding solution. First I will declare the visitor and stack array. So So the stack array used here is to find the cycles in graph. As we discussed before, if the graph any cycles, you can't take any courses. So we will find if the graph has any cycles with the help of stack. I will explain it later. So first we will construct the adjacency list from prerequisites, because the adjacency list is more easier to iterate through. So we will declare a dictionary for requisites. If I may be doing this list, it will be list of that happened of j. So we will be underscore list of I equals to j. So yeah, now that's done. We have constructed the adjacency list. Now let's continue with the function, which is I'm gonna call it as topo. Here in between, I'm gonna create a cycle of array called as false. So initially we consider there will be no cycle in the graph, and we will move for. We will see if it has. So we start with node. If the node is already visited and it is in the correct recursion stack. So if it is in the correct recursion stack, then I'm gonna set this cycle of 0 equal to true. Then I will return if no if cycle of node equal to, sorry, I forgot the one here. Then I will just return if the node is already visited, but it's not on the it's not but it is in the stack, so I don't have to iterate to the node again. I don't have to find the adjacents of the node again. So I will set the node as visited, stack of node equal to 1 if node in edg underscore list for I in edg underscore list of node. I'm gonna call the function again with so, and then of node, and then I'm gonna take the node from the stack. So here means the node is not in the stack anymore. So now for I in range of num courses, I'm gonna call the function topo of I. Forgot to declare array. So return arr if this cycle of 0 equal to false, else. So if there is a cycle, I can't take any courses, so I will have to just return an empty array. So let's try out this solution. Let's run and see if this thing works. Prerequisite. So sorry, I missed an S with D. Yes, this thing works. So why do I use the stack? Let me explain that actually. Let me explain it a bit clearly. Consider that I have a dependency like this. So I will start from node 1, which will be in my recursion stack, and then I will go to node 2, which will then add it to the recursion stack, and I will go to its dependency 3. So when I see, so I will have 3, and then I will call the function again on the dependencies of node 3, which is 1, and it will it will be in the recursion stuck previously. So this creates a cycle, which this will again create a cycle like this. So in order to deduct the presence of cycle, I'm using a separate variable called as stack. It just used to check whether it's a node is it's a node is being iterated again, or if a node is being recursively called again for the second time. So that's how I use a stack to check whether it's a cycle or not. So let's sum this solution. Yeah, we passed it with beating 62% of the solution. So thank you guys. See you again tomorrow.